Hello, myself Naveen Kumar Saini. In the course Microprocessor, code KCS403. So today we are going to discuss about 8255 Programmable Peripheral Interface. So this is very interesting topic because this is a programmable peripheral interface. So it means we can program that IC as per our requirement, and the IC number is 8255. So there are some of the silent features of this particular IC. So it is a programmable general purpose IO device. Okay. So this IO device means input output device which can be programmed as per requirement of a programmer. So in that it has a 3 8-bit bidirectional IO ports, and these ports are port A, port B and port C. It provides 3 modes of data transfer. So first is the simple input output mode, second is the handshake IO mode, and third one is the bidirectional handshake. And additionally it can also provide a bit set reset modes to alter the individual bits of port C. So the key points of this 8255 is, so as we are aware, we in the center we have the IC, in the left hand side we have the MUPI, and the right hand side is defined by the functionality of the IC. So this is the completely common to all the architecture of different ICs, just like 8237, it may be 8255 which is we are going to discuss, and 8259 which is cascade interrupt IC. Okay, so there are various ICs in which these things are common. So this in this position, in the right hand side of this IC in the diagram, we will see that which carries the port A, port B and port C. So this is a scenario where we will talk about 8255 IC, and in the left hand side, as I said, microprocessor will be there. So this microprocessor can be 8086 microprocessor or 8085 microprocessor, or any of advanced version of the processor will be there, which is connected with the particular IC. And in the right hand side is representing the functionality of this particular IC, just like input output devices can be connected with that. So in that IC we have 3 ports, port A, port B and the port C. So these 3 ports are connected with the IO devices. So in that IC we will see that port A is it will be from PA0 to PA7. So this is the 8 line IC port of port A. So we see that pin number 1 to pin number 4 is PA3, PA2, PA1 and PA0. And here we can see that PA4, PA7, PA6 and 7, these are the port A. So port A comprises the 8 lines. Similar to that, port B, which also comprises the 8 lines. So these 8 lines will be PB0, PB1, PB2 and PB4, PB3, 4, 5 and 6, 7. So these are the port B, right? So this was the port A. Similar to that we have the port C. So this port C is from here. So this one is the port C, right? So PC0, PC2, PC4, 5, 6, 7, and then we have the other PCs which of this IC which is from the PC0 to PC3s as well. Okay, and then we have this D0, D1, D2, D3, D4, D5, D6 and 7. These are the data lines which is available for the data transfer, or we use the data bus for that. Then we have the VCC and the ground, and we have the reset, WR bar write signal, and then we have the read signal as well into this. Okay, so then we have chip select also. So chip select is used for the enable or disable the IC, particular IC. Okay. Then we have A0, A1 and A0. So this A1 and A0, these two pins are connected with the MUPI, and this is responsible to tell to the IC in which mode this IC will work, which port will work as an input output. So these two pins A1 and A0 will tell the port A will be in use, port B will be in use, port C will be in use, or the control word register will be used into this. So simple instruction for that, if we have the in AL15, so this 15 is nothing but 15 is the port address. This is the example. This is the port address. Okay. So content which is available at the port 15 will store into the AL register. Okay. So here we see that AL, if we have, so we can replace this in the different ports. We can connect different DIP, dual input package. So these are the switches. Okay, so these are the switches which can be connected at the different ports or the input ports. Okay, so we can replace this with some DIP, as I said, dual integrated packet, so in which the switches are there. So these numbers 111 and 00000. So this number can be represented here. Suppose we have AL register contain the OF, so this is nothing but the OF, and this will store into this IC, and the output will be appear at through this pin. Okay. So what it shows in this case, if this is the inputs for all these switches 1, 2, 3, 4, 5, 6, 7, 8. So this switch inputs will go into the AL via 8255. So this in instruction meaning is what? This is the content which is available at the port number 15 will move into the MUPI. So this number will move into AL. Okay. So this will look like this. Okay, so in place of the diodes, we are just simply using this DP. Okay, similar to that, we have the out instruction. So what this out instruction says, out 15 comma AL. So content of AL will move into the port number 15. So AL is the register which is in the 8086 microprocessor. So the content of this AL register will move at the port number 15. Okay. So this AL will be appear into this LED. So it shows that these are the 8 LEDs, and these 4 zeros are representing the off condition of these 4 ICs, and the ones of this will represent the one of enable this IC or the switch on the ICs or these LEDs. So this is representation of the out instruction. Now we come to the architecture of 8255. So this architecture of 8255 comprise in two parts. So internal is the internal data bus. So as I said previously, in the left hand side of this internal data bus is connected with the microprocessor. So this side will have the microprocessor, and this side is the main functionality of the any of the IC. So in the left hand side we see the data bus buffer. So D nodes at D7, this is connected with the MUPI. So data input or output will flow through this data bus D nodes at D7. Then read write operation, read write control logic. So these two are the basic building block of in any of the IC, because this is connected with the MUPI. So read write control logic will have the read signal and the write signal. So at one time read signal will be activate or the write signal will be activate. So these are control signals. Then reset, this reset pin is used to reset the any of the register in the control word into this IC. That may be the control word register, or it may be the numbers at the different ports. Okay, so this can be reset. Chip select is used to enable or disable the IC. A0 and A1, these two pins are connected with the MUPI, and these are responsible for the which port is going to be select. So if A1 A0 is 0 0, then port A will be selected. If it is 0 1, port B will be selected. If it is 1 0, then port C will be selected. If it is 1 1, then the command word register will be selected. Okay. Then port A will be of PA0 to PA7, port V will be PB0 to PB7, and then port C will be PC. It is divided into two parts, first 4-bit pins and the higher 4 pins. The lower 4 pins are PC0 to PC3, higher 4 pins are PC4 to PC7. Okay, so this PC0 to PC3 is called the port C lower, and PC4 to PC7 is called the port C upper. So these ports are controlled by the different control groups. So in the control group A, this is connected with the port A, complete port A, which is of 8 lines, and the port group A will also contain the port C upper. So it means PA0 to PA7 and PC4 to PC7, these two are in the group A. Second is group B, port B, and the group B port C lower. So this combination, so this one and this one, so this combination is controlled by the group B control. Okay, so in this way these different ports are controlled by the group A control or the group B control. So as I said, the significance of these different ports are used to connect the different IO devices. So the pins which I said, PA0 to PA7, these are the pins which are connected with the inputs lines or the output lines. So these are architecture description, that this is a 8-bit bidirectional bus buffer used to interface the internal data bus of the 8255 with the external data bus, and CPU transfers data to and from the 8255 through this buffer. Okay, so data bus buffer, so it is used only for the data transfer between the IO device via 8255 to the MUP. Okay, so it can be, data bus buffer is connected externally to the microprocessor 8086. Then we have read write control logic. So this read write control logic, it accepts addresses, control signals from the MUP, and control signals which determine whether it is a read or write operation, and also select or to reset the 8255. So different operations which can be performed through this read write control logic: read operation, write operation, A0 on A1 inputs for selecting the different ports, reset the 8255 and the chip select to enable the IC. So these are the functions which is available. Then we will focus for this, if 8255 these both are 0, then we say the port A will be selected, and 8086 these two signals 0 0 will be A2 and A1. So inputs line from this and the address lines of A1 A0 is connected. So 0 1 0 1 the port B will be selected, and then 1 0 1 0 port C will be selected, and if it is the 1 1 then the control word register will be selected. So these are the sample addresses of these different ports which can be controlled by the control word register. Okay, so in group A, as we said, the port A and port C upper. Then group B control will be take care about the port B and the port C lower, and port A, port B and port C, because these can be used as a bidirectional ports, so it can be programmed in various modes of operation. So this functionality will be depend upon the mode 0 where all the ports are there, mode 1 where the port A and port B will be used as a data bus buffer to transmit the signals, and in that the port C is not used for data transfer, it is only used for the handshaking signals or the control signals. In the mode 2, the port A is used for the data transfer, and port B will be into the mode 0 or in the mode 1. Then port C in the mode 2 also, this port C is not used for data transfer, but it is used for the handshaking signals. So here it is mentioned that only the port C can also be programmed to work in the bit set reset mode to manipulate its individual bits. So what is significance of that? This is very important point, where 8255, which operates on the two modes or the two modes of operation, where the D7 bit will select will decide that the 8255 will work in which mode. Okay, so it may work in the BSR mode, so it depends. If D7 is 0, then it will work on the BSR mode. If D7 is 1, then it will work on the IO mode. Okay, so in the BSR mode, what is the functionality of this? That the port C only will be used for the BSR mode and no other effect on the IO modes. Okay, if this is the case, when we have the D7 is equal to 0, and when D7 is equal to 1, then it will work in the IO mode, and thus IO mode is in three parts: mode 0, mode 1 and the mode 2. So if it is the mode 0, so simply is the IO mode, and for all the ports of ABC, as we have just said, in the mode 0, port A, port B and port C are used for the data transfers, and the mode 1, port A and port B. So here we can see the mode 1 is used for the IO connections, A using the port A and port B, but port C only used for the handshaking signals. Then we have the mode 2, so which is use the bidirectional data bus for the port A. Then port B is either in the mode 0 or in the mode 1. Port C is used for the handshake. Okay, so this will be used as the handshake signal. Clear? So this is the mode of operation of different 8255, which depends on the D7 bit of control word register. So for any IC, so which connect between the IOs or with the MUPs, so every IC has a control word register, and this control word register number is given by the MUP, and based on the control word register, which is you can say this is to initialize the IC. So how we initialize the ICs, what the function we have to take from the IC, or the IC what function it will do. So this will depend upon the these bits control word register. So in which mode these things will be working. So in the if we talk about separately control word of 8255, so we will briefly discuss the BSR mode, which is only for the port C, and BSR mode is only for port C. As we said, in this mode individual bits of port C can be set or reset, and it is very useful as it provides 8 individual controllable lines which can be used while the interfacing with the devices, an A to D converter or a 7-segment display. So these individual bits is selected and set reset through the control word. Okay, so since D7 bit of the control word is 0, the BSR operation will not affect the IO mode operation of the 8255. Clear? So this is the format which is representing when D7 is 0. So D7 is 0, it means this will work on in the BSR mode, bit set reset mode, and in that case this is the don't care lines, right? So here I want to say that based on this D7 bit, all these bits functionality will be changed, right? If it is 0, so these bits will separately function in different way. If it is 1, then these bits separately perform another task in another way. So just like if D7 is 0, so in that case this is the bit set reset mode, and in this case D6, D5, D4, these are the don't care cases where it will be used in the further uses. D3, D2 and D1, so these 3 bits are used for the bit select, where the 000 representing the 0, 001 representing the 1, and 010 representing 2, 011 representing 3, 100 representing 4, 101 representing 5, 110 representing 6, and 111 representing 7. So these are the bit select, where the inputs at this D1, D2, D3 will define which line is going to be select. Then we have D0 bit. So this D0 is representing the bit set or reset. Individually we can set or reset all these bits. Okay. Then we have control word of 8255, which is in the IO mode. So when we talk about the IO mode, so it means the first of all we will see the bit 7. So when we see the bit 7, it is representing the 1. Okay, so if it is 1, it means this mode of operation of 8255 is in the IO mode. Now it depends, this IO mode may be in the mode 0, maybe in the mode 1, or maybe in the mode 2. It depends. Okay, so to do 8-bit data transfer using the ports A, B and or C, 8255 needs to be in the IO mode. So the bit pattern for control word in the IO mode is as follows. Okay, so I have, you can take any of the example where in this case, if I want the what would be the control word if it is working in the IO mode. So if it is working in the IO mode, it means this bit will be 1. Okay, second, if I am saying the mode port A as an input, so if port A as an input, so this bit will be, so port A as an input, so it means this pin will be 1, right? Okay, so if I am saying the port A is input and port C as an output, so port C as an output, so if we say this is the output, so this will become 0, and in the control A and in the group A and the group B also, if this is also as an output, so this value will be 0. If I am saying the port B is into the input mode, so in this case this value will be 1, right? So port B is the input mode. So what left? Mode 2 and this one. Okay, now we can see that the port A is in the working, port A has some functionality, port B has some functionality, and port C also has some functionality. So in which mode these three port A, port B, port C, all these three will be into the mode, into that active mode or the for data transfer. So this one will be only in the mode 0, right? So if this is in the mode 0, so automatically we can say these bits for this one will be 0 0. Okay, and now this one will also be 0 mode. Clear? So I hope this point is clear to all of you. So we have to decide, we have to see the which port is in used for the data transfer. If port ABC both all the three are in data transfer, it means it is a mode 0 case. If port A and port B is used as the data transfer and port C as a handshake, in that case this will be in the modes 1. Okay, if the port A is used for data transfer and port B is used in the mode 0 or mode 1 and port C as in the handshake, so in that case this is the case of the mode 2 operation of IO modes. Okay, so how we can define all these modes? It depends on this bit D7. So in this case what is happen? So now the in that case what we are getting? We are getting 1 0 0 1 0 0 1 0. So if we combine this, so what will we have in the control word? So this one is nothing but this is the 9 and this number is 2. Okay, so it means in the control word register we will have 92H. This is the 92H. So this number 92H will be into the control word register. So for that one we can write the function for this. How we can write? We can write the move AL comma 92H. Okay, so 92 will move into the AL. This is the immediate addressing mode, and then we can write out CWR into AL. So this is a representation how we can how we can store the CWR as 92. I think this point is clear. So we have to think ourselves by the condition that which port is using and in which mode. So based on that, control word register must be this one. So how to write the program for this? Simple. First of all, put the 92 into the AL register, and this is in the 8086 microprocessor, right? So this instruction which we are writing 8086 MUP. Clear? So 92 is stored into the AL, and then AL CWR comma AL. So AL content will move into the CWR. So in that case, CWR will carry the 92H. Then we have the operating modes, as we said, mode 0. This is the basic input output mode. where there is no handshake signals are there. PB, here we can see that PA0 to PA7, PB0 to PB7, and the lower PC0 to PC3 and PC4 to PC7, these are used as the input output mode. So this is nothing but this is the mode operations which is used in the mode 0, where the read write is the control signal which is coming from the control bus D0 to D7, which is connected with the data bus, and the A0 and A1, this is the address lines or address bus which is coming from the MUP. Okay, and CS bar is the chip select which enable or disable the 8255 IC. Then similar to that, we have the mode 1, as we said, used for handshake input output operations. Port B is initialized in the mode 1 for either input or output, and pins PC0 and PC1 and PC2 function as the handshake signal, right? Port A can also be configured as input output in the mode 1, but handshake signal pins are not same for the input and output modes as like port B. So if the port B is initialized in the mode 1 as the handshake input port, then the pins PC3, PC4, PC5 function as the handshake signals, and PC6 and PC7 are available for using as the input lines or the output lines. If port A is initialized as a handshake output port, then PC3, PC6 and PC7 this function as handshake signals, and then PC4 and PC5 will be available for using an input or output lines. So this is the collaboration of different using port A, port B and port C, which pins are used for the data transfer and which pin will use for the handshake signals. Okay, so it is a representation of control word. So again it will be one only because this is a operation mode. So this is the scenario where we want write control word for the port A as input port, port B as output port, port PC upper input and PC lower output. So when we put all this value all together, then we will see that control word which we will get BC must get it. So the program for this one is like this. So this is the program and this is the example which you can go through it, right? So just put all this value all together, then automatically you will see that the result is B and C, which you will get it. Okay, these are same as we have discussed in the previous case. Mode 2, which is a basic functional definitions, only the port A, it can be port A can be initialized in the mode 2. In the mode 2, the port A can be used for bidirectional handshake data transfer. That means data can be input or output on the same 8 lines. Pins PC3, PC4, PC5, PC6 and 7. So all these 5 lines used as handshake lines for port A. Port B is operating in either mode 0 or mode 1. If port B is in the mode 0, then the PC0, PC1 and PC2 are used for the IO modes. If port B is in the mode 1, then the PC0, PC1 and PC2 which is used for the handshake lines. Okay, so I hope these cases and different cases of mode 0, mode 1 and mode 2 are clear to all of you. So here the last point of mode 2, that is to write the control word where the port A as an input port, port B mode 2 as in which this mode will work, and port B as output port as in the mode 0. So which will be defined previously, right? So this format is very important. So each one of you must know about how to write the program for this. Simple 2-line program is there which can be used to write the control word by using the different cases, right? So we have to just simply find what is the port A case and port B and the different in the modes. So these 3 cases are very important in a summarized way. Then the mode 0 is mentioned here, port A, mode 1 and the mode 2. So this is the complete architecture which we have discussed about 82C55. So this IC is there. Okay, so on the mode 0 all these things are used as the data transfers. In the mode 1 some lines are control signals or the IO lines, but port A and port B can be used as a data transfer. In the mode 2 we can see some port A will be bidirectional lines and port B is also bidirectional lines, but somehow this port C can be used for the control signals. Okay, so this is the complete description about the all the complete architecture of 8255 in the mode of operations. So I hope this was the simple IC of 8255 which I just said. About all the numbers are simply mentioned there for all the ports from port A, port B and port C. These are the simple meaning of all these ports. D0, D7 data bus, reset input, CS bar, chip select, read input, write input, port A address, port A, port B and port C, and so on. Okay, I hope you got so many things out of this lecture. Thank you very much.